Hello, everyone. My name is Devin Ulabari, and I'm with Sugar Labs. And today we're going to showcase some of the work from, one cohort of students from Google Summer of Code, from dedicated mentor projects with Code for GovTech and Sugar Summer of Code. So we call them GSoC, DMP, and now SSoC, I guess. So today we've got AdityaKrSingh, we've got Diwangshu Kakoty, Suneri, Muhammad, Haroon, Shubham Singh, ElwinL, Nikhil Bhatt, Safwan Sayeed, and Saumya Shahi. So we're going to check out their work. They're going to show us some of the cool things they worked on this summer. I've given each presenter about 5 minutes to show what they've been doing, because we've got to fit all of the contributors into an hour's time. And then next week we'll have a second cohort also present their work. So I hope you can also join us for that to see some of the cool work they've done this year. So we've got a wide representation of different projects here for Sugar Labs. So Sugarizer, which is a multi-platform version of the Sugar desktop environment. We've got Music Blocks, which is a visual programming language for music, including some new and exciting extensions for that and some new backends for that. We have some new and improved Sugar activities represented today, as well as Music Blocks version 4. And I've done my best to kind of group them, the presenters, by similar projects in terms of their order. This first group is also the group that's finishing their projects first. Their deadlines come first in terms of DMP and GSoC. So that's one of the reasons why they're going today. And this is all part of their final report, if you will. So I guess with no further ado, we should get started so that we can end on time. So first we've got AdityaKrSingh. So Aditya, would you like to show your work?
Sure. Okay. My screen is visible?
Yes.
Okay.
We can see your screen. Thank you.
This summer I have been working upon 2 activities. The first one being the human body activity. Basic fun of this activity is to teach children about the different parts of human body, let them explore around and collaborate with each other with fun quizzes. So over here right now we have 3 different models. The first one being the human body model. It's an overview of skin, arms, shoulders, hairs, and all sensory organs. Moving on, we have the skeletal system. Just a second, it will take some time to load. Okay, and also we have the organ system, and we have implemented 3 modes in this: the paint mode, the tour mode, and the doctor mode. Okay, I guess the skeleton model has loaded. So the skeleton model has more than I would say 30 to 40 sections with different things. We'll see them in the tour mode. And moving on to organs model, this might take some time. It's a bit heavier model, I would say, very large meshes. Okay, let's go. So students can easily learn about different organs, how they are placed, and what are their positioning in the body. And let's take a quick look at the tour mode. The tour mode helps the student to learn different models line by line, as if this is brain, then moving on to this is lungs, etc. and etc. We can easily move to doctor mode, and in the doctor mode, the students, it's like a simple quiz, and students can easily help identify what parts are. And when entering the shared mode, it will be, I guess, this might have some bug. The activity has a few issues we are still working on. And in Dr. mode, in shared mode, it's basically like all the students will get a prompt. Okay, this part needs to be detected, and the student will click on it and will get a rating and rank who is had the highest score. You can easily save this image and use in other activities as well. Moving on to the next activity, we have Stickman Animator. This is an animation studio to help students understand the basic of animations, how keyframe animations is done. Over here, we have the play and pause button, the speed button to remove Stickman, add Stickman. We also have different templates like running, and we have boxing, different types of dancing. We can import an existing stickman activity as well. And we also have the feature of importing a stickman from a video. So if I take an example, we can like a student can record himself walking or doing something and something, and it will process the video and create a stickman from that using TensorFlow and PostNet. Since we are on a time crunch, this might take a time. I'll skip this feature. Okay, so I'll just quickly show you how this works. I'll just increase it. Okay, so over here we inserted the running template. Similarly, we can insert the boxing and dancing as well. Okay, so the one key feature is the onion skinning part. The onion skinning part shows what we implemented in the previous frame, and using that guideline, we can implement in the next frame. Okay, similarly goes with the shared mode. In the shared mode, multiple users can join on the same canvas and create their own stickman, maybe create some animation movie or something like that. It will be really fun. Okay, so that was it for my presentation, and this was my project done this summer.
Awesome. When I was checking out your blog post, it really struck me how, you can have like a video, I guess, of like a person moving around, and it can detect the different joints.
Yeah, actually, it might take some time. For now, we are using two architectures, that is MobileNet and ResNet. Since I'm using a laptop, so we are using a ResNet model, which is a bit on the heavier side, but an accurate model. So this might take some time. If we have the time, I'll just show it quickly.
Yeah, sure. I mean, we're almost there. And what did you learn as you were doing this project?
Okay, so I'll talk about the most interesting part of this project was the joint hierarchy. The like earlier we were using each joint was independent to other joint, but the problem was okay. So it's like this. Currently, this is just a static image to test, and image joints are detected, and the stickman is mapped over here. Okay, I can just insert the stickman. So coming back to the joint system I was talking about, the hand is a free movement, but the elbow is the parent of a hand, and the neck is the parent of both elbows, both hand, and the head. So I had to implement a joint hierarchy system, and even that uh, I in the hip, but I don't have to have a joint in the hip. This is a drag moment, and when moving a parent, I have to keep the relative position of all the joints of its children, so that if a joint moves by 30 degree, all its children must also move by 30 degree. This was like quite a tiresome task. Me and Lionel had to like brainstorm for a week or two. And the second big thing that I learned was mapping real human to the stickman, managing the constraints, because a human body can have different proportions, and the TensorFlow can also detect different proportions. But over here, I need to keep the constraint so that if a human body is a small, if it's a child, his or her height must be 3 feet, 4 feet. But if it's a adult, his or height must be 5 feet. So, but on the
Yeah.
canvas, I need it to be a same height. So the mapping of constraint was a really difficult task. And in the human body system, I would say finding the correct asset was a very difficult task, and again compressing it so that we don't lose the consistency of the asset. It remains very high quality, but also it's low enough for edge devices. This was a really challenging task for me.
Great. Thank you so much for sharing. Great work, Aditya. So next we've got Diwangshu. So Diwangshu, if you can.
Hello, everyone.
Yeah.
Okay.
Hello, we can hear you. Take it away.
All right. Let me just share my screen. All right. Can you see the screen?
It's loading. There it is. We can see it.
All right, cool. So, hello, everyone. I am Diwangshu. For this year GSoC, my project was to build a reflection learning chatbot. We have implemented this chatbot in a widget in music blocks. So, first of all, why do we need reflection learning? As you know, Sugar is an organization focused on education. It is important to have a tool which teaches students how to do reflection and how to effectively learn. So let me just start my demo. Here I have a code, and this is supposed to draw a golden spiral. And I will turn on my widget, and it will initialize the reflection learning process. So as it is thinking about, okay, so it is saying that this code appears to be generating a spiral pattern, possibly a golden spiral, like a Fibonacci, and yeah, it is absolutely correct about it. So yeah, for things like this where you have an algorithm which is generating a pattern, then it can recognize very well. If you have a music, then it might not guess the song that you are trying to make, but it will definitely know what kind of music you are trying to make. But anyway, so moving on to the features, we have three mentors over here. One is Rohan, the second is Alan K, and third is Beethoven. So Rohan is for general reflection learning. So if you, let me just type in something. So for general reflection, you can go with Rohan. If your project is very coding oriented, if you want to do reflection on your coding skills, then you can talk with Alan K. So let me give a quick hi to Alan. Okay, so yeah, this is how you will be talking with all the mentors. And the third feature is the summary or analysis report. Right now, this will not work because to generate an analysis of your reflection, it needs sufficient amount of context. And for that, I have set a limit that may be 10 messages, I think. So after 10 messages, you can use this analysis feature. And the next feature is to save this whole conversation in form of a txt file. And this is a refresh button. So if you have edited the code, you can refresh use this button so that it will get the latest context about your code. So yeah, this is what it does. Let me show you what it is storing in the local storage as well. So out here, here it is storing the analysis of the previous project, right? When I will click this button, it will store this kind of report in your local storage. And when you are using this analysis feature again, then it will compare the conversation that you had with this report, and it will try to come up with your journey about how much you are learning. So yeah, this is what it does.
That's awesome. Thank you so much, Diwangshu. I was thinking, maybe it should gray out that button until you have 10 or more kind of conversation points, and then that'll
Yeah,
signal to the user.
that I have to do. I think that it uses the music blocks messaging thing, that notification, to it notifies the user that you don't have enough context, but
Okay.
because the widget was it was covered up.
Yeah, this is great. We're really excited about this. So this should give learners an opportunity to, get some feedback on their work, but also kind of, without giving them the answer, right? Kind of
Yeah.
guide them to, next steps. And I've taught music blocks in the classroom for a while, and it is helpful. Of course, as a teacher, I can kind of give them next steps, but some students, like, some self-guided time. Also, I can only be in one place at a time. And even if I have helpers, they might not be able to, assist the student at a particular time. So
Yeah, I definitely. I would like to hear all the feedbacks from all the young learners. So keep
Yeah.
me informed about it.
Great. Okay, so next we've got Suneri. So if you can turn on your mic. Yeah.
Yeah. Hi everyone.
Hello.
Myself Haroon, and let me share my screen first. Is my screen visible?
Yes,
Yeah.
it is.
So in the past few months, I was working on the debugger for music block, which is AI powered. So like, what is the requirement for this project? Like this requirement, I felt out as the most important requirement. I was just attending an org meeting, and one of community member just tried to debugging his project and just stuck in between, and he was unable to get out of it. So we just thought of came up with an idea of AI chatbot debugger, which would be in a form of widget. So as soon as a person is creating a project and stuck in between any of the things, like any logic or any of the guide, like if I was unable to understand like where the guitar, how can I choose the drums, how can I choose the guitar or anything, so he can just pull out the debugger widget, and as soon as the person clicks over the widget the debugger widget will welcome you with an proper understanding of the project at its initial stage. Now what happens if I want, if we'll read and it's getting it right, that the project is all about three notes melody playing in guitar. So if I type in something, okay, I have heard it before. Okay, so we'll ask the debugger to add some more drums in the project, and let's see its output. So the need of the debugger is most important while we are running on any project or any of the coding stuff. So I thought this will help users to debug their project while creating something, while add on something. Like it shows you the most important, the major improvements you can make in this project. So yeah, it answers us. Also, like it will guide us to how to add some drums. So the debugger is AI powered. Currently, it's using the response game as it's fast. So Yeah, so here it gives us a simple change in the project. Like we can just set instrument, copy our notes, then change the set instrument to snare drum and put it on the third beat if you want to try that. Or it gives us some more opportunities like to try something else or anything. Maybe the possible thing and the most important improved thing in your project. So it will guide you through all of this thing. Again, for this debugger, we have proper error handling. Like the errors are properly answered. Like if I refresh the conversation, so the conversation is reset and it aligns uh, with the music blocks environment. So in the form, like we have a feature of resetting conversation. It will restart the conversation from the start. Also, I have added here, like whenever a project is changed, the project code is sent to the debugger backend every time you type in something new. So like if I added a drum, so it will consider that new project, not the old one, and you can just go on the flow with your chat and get some answers and get some new vision. Also, we have a export chat button, so you can just show off this chats with your teachers, your peers, to get some more information or help us to improve the feature. So yeah, and I have also written some of the best documentation for this project. If you are a contributor and wants to maintain this project, you can just jump into this repository uh, of in Sugar Labs organization. So if you are a user if you are a user and just want to take a look and understand what the debugger is and how it works, so you can just read our debugger, the user guide. uh, yeah, also we have a widget guide, like if you want to change some UI section or anything, like if you are about to do some more improvements in the UI section or the widget section, you can just uh, like give us a PR on this aidebugger.js file in the widget section. Also, in the past 12 weeks, I have written a vast the my journey over this period of Sugar Labs in our blogs. So you can also read our blogs. So yeah, that's from my side
Great. Thank
for
you
this
so much,
summit.
Suneri. Yeah, so I think that, complements the reflection tool quite nicely. So now we've got reflection and debugger. And next we've got Muhammad Haroon, who's going to show us, a little bit of what we've been doing with regard to samples.
Hey everyone. So this summer I was selected for Sugar Summer of Code, the pilot candidate, and I was working on AI sample generation and particularly audio trimmer feature into music logs. So just let me share my screen and let me have a quick demo for it. So this is how the AI sample generation feature works in music blocks. So basically, we can add like a prompt. It's basically using a text to audio generation model. So we are putting a prompt like what the model should generate sound like. So after putting up a prompt and hitting a submit button, the it would be like start generating the audio. After some time, when the audio is generated, it will take some time. And then we can particularly also save them into our folder from where then we can then import later into trimming functionality, which is also being implemented into music blocks. So the need for this particular feature was so that students can get limitless opportunities to create AI generated sounds, because at the moment they are limited to few of them only. So this gives them limitless options for creating the sound and then importing those into the music block. Initially, like what was there a problem was that we could not find a particular model like which could generate sound samples which can be directly imported into music logs. So what we discussed after discussing with my mentors, we came to a conclusion like to create an audio trimmer into music blocks, so that we can trim a particular segment of that audio that can be in each ported into music block and that use that sample. So yes, this was my project which I have been working on. Thank you.
Great. Yeah, Muhammad, I'm excited about the work we've been doing on this. I've heard from a lot of music teachers over the years that that they want, a bigger sound library. They want different sounds, and we kind of started to explore this as a possible way of expanding our library, which is kind of a trickier, problem than you might imagine. The sampler widget, for those that are not familiar with, you can always, sample like your own sound. So, for example, if you like, your instrument sound, you can use the sampler widget, and just play a note as well as you can. Just try to play it with a nice even tuning, consistent tone, and then you save it, and then you can use that to be your instrument within the visual programming language environment as you're performing things. Um, the hope with this is that you can, without an instrument, kind of imagine a sound that might not even be a real instrument. Something like between a bell and a songbird. What does that sound like? And the language model does its best to, try to, fuse those two sounds together, and then give you something that you can then use within the programming language. So once we crack this nut, I know that a lot of music teachers will be excited about the prospect of having, more sounds. Great. So Shubham Singh, I've got you next.
I
Hello.
hope that I'm audible.
Yes, you are.
Hello everybody. My name is Shubham, and I was selected in GSoC this year for Sugar Labs, and I would like to share my screen with everybody. So as you can see over here, my project was a color sensor for music blocks, where we had to create a Lego bricks block for the Lego notations for the visually challenged. The Lego bricks block can be accessed through the widgets. You can search for Lego bricks and you can access it from here, right? So the main features of Lego bricks widget is that you can basically either use a webcam image, right? For now, the webcam is like, and or you can just upload an image of Lego notations. So, what are Lego notations? It's basically the pitch notes mapped along with their durations. So, for an example, the 8 blocks over here, the 8 stubs of Lego bricks over here, those are like this is like a eighth note, a whole note, and half of it is like half a note, and then we can go for 1/4 as well and 1/8 as well. So, for an example, if I place it over here, and I can even adjust the column spacing over here, the instructor can, right? So what this project is about is that we are trying to help the visually challenged people through making them actually feel the Lego music notations, right? If they have something that they can actually feel and manipulate, so they can create music from that. It gives So what it's actually doing is basically scanning all those blocks and writing down their durations of how long did it take to go across the blocks, how many stubs were there, and on the basis of that, it So as we can see on the basis of the image that we have put over here, it generates accurate music accordingly. And you can even export it as like a music blocks action block over here. It's exported as a Lego phrase. And we have also added options of like, you can choose elegantly between the instruments that we have over here, for example, piano. And you can also like click over here so that a visually challenged person or a student might be able to like be guided better, right? I can also want to demonstrate like an example where I have taken an actual webcam image over here, and let me make it across the stubs. Hold on a second. So the y-axis lines and x-axis lines are made so that across different widths and sizes of computer screens, the lengths and durations don't mismatch each other, right? Uh, so as we can see, the color detection is pretty accurate. The image is kind of distorted and I didn't put it into correct positioning. We can even export this project and into the Lego phrase music, and also try it out with different instruments over here. Yeah, that's it for the project, and I've also put in some good examples over here of different generated outputs. For an example, this same webcam image, if placed correctly on the Lego bricks, it would give a very accurate output like this. And yeah, that's it for my side for Google Summer of Code this year.
Awesome. I could say much more about this project, but I'm looking at the clock. I'm super excited about this personally. And I imagine that it will also help, even younger learners, because now you have a physical manipulative that represents, music, which can be really nice for younger learners as well. So, and one thing that Claudia Rea, who's one of our board members for Sugar Labs, suggested was like, you know, you have a camera up here and you have kind of like a, you know, not a tripod in this case, but maybe a quad pod because it's got like 4 legs or something, so that you've got a good vantage point in a very, you know, clear place where you can get a nice accurate image that's unchanged.
That's right.
Whereas if you're doing this, you know, you'll get a shadow or something like that. So you know, doing those two things together, I think, you know, will make that really, really good. Okay, so next I've got a video by Elwin that I'm going to show. So.
Hello, so this is my GSoC project showcase. So basically I worked on the JS editor and also a music blocks generation slash MIDI upload tool. So the first thing I did is improve the JS editor. So small things first, I added more syntax highlighting. And I also added the ability for users to add debugger statements in their code. And the main part of this project is the convert JavaScripts to blocks. So we can already convert blocks to JavaScript, but now we can use this conversion to turn it back into music blocks. So that was the first project. And also you can see if we add debugger statements and we convert it, then they will show up in the blocks. And if we can run it, then they will stop at the debugger blocks, as you can see here. And that's the improvements for the JavaScript editor. Okay, and the second project I did was AI music blocks generation. It's in the, basically how this was done is that I used the Gemini API to generate a MIDI file, which then there was already existing code to convert MIDI into music blocks. So I have 2 modes. So first you can import an existing MIDI file, and another mode where if you gave it in query, then it will generate the MIDI file and convert it to music blocks. This one takes a long time to generate, so we can just showcase actually importing a MIDI file. So if we just like choose one, and then it'll only, there's a limit because it'll take too long if the file is really big. So if we just give it a little bit here, yeah, even I guess 600 is big enough to have it pause for a while. Oh, yeah, I guess the only problem with this right now is it takes a long time to load and stuff. But hopefully this does load at some point. Oh yeah, in the meantime, I also added like an API key manager widget. So we won't need to use our own API key. We can have the user like input and load their own Gemini API key, and they will use that for their own generation. Which will be this one up here, API settings. I'll show that after this loads. Oh. Oh yeah, and how the AI generation was done was using a RAG pipeline, and I have a large data set of different types of music that it can then retrieve based on the query and generate something better than if it was just a prompt by itself. It's loading a very long time. I should have set less notes, but yeah, it works. Yeah, as you can see here, we can also set API key, test the connection, and then save. And then once that's saved, you can, okay, wrong one. You can then use this and convert. But yeah, there's a long time. Let me see if I can reset this. Let's do like 100. Yeah, there we go. Okay. See, yeah, that's how that works. That was my projects.
Awesome. That's actually an incredible amount of work, and it's really great that he kind of picked up the baton for the JavaScript editor, because that's a really powerful idea. Because the entire idea behind a lot of sugar tools, all our tools, is that they're waypoints and not destinations. So we're not trying to get someone like 2 music blocks and then just stay there. But a young learner is using music blocks, they're learning things, and then they can go to Lily Pond, for example, which is one thing you can export to. They can export it to something that MuseScore understands. And they can also, export it to JavaScript and learn a little bit more about JavaScript, and they can kind of go back and forth between these different worlds. So that is particularly awesome. Nikhil, you're next.
Yeah. Hi, Devin. I hope I'm audible. Let me just share my screen.
Yes.
Yeah. So my project for this summer was to introduce students to the concept of Git through music blocks. And let me just demonstrate how my projects work. So the project also plans to, transfer the current project storing system, which is the Planet system, and integrate this new Git-based project storing into the music blocks project workflow. So let me just demonstrate how this works. So for example, this is the screen which student sees, and he creates a project. Let's say now this is initializing a repo inside a GitHub is equivalent to creating a project inside the music blocks. For example, I now create a new fresh project, and I click on this initialize a repo button, and it asks me to enter a name. Let's say I enter a sample project, and I give it a theme, just like we used to do in music blocks Planet system, and a description of the project. Let's say sample project description. And what it does is it will create a new project inside the GitHub, inside the Sugar Labs centralized GitHub repository, and will allow us to interact with that project. So let me just complete it, and an API call will happen, which the backend for which I have created during the summer, and now the project is successfully created. So Now, if I want to edit this project in future, I can also do that. So let me just add a couple of random blocks over here, and I will just click on the push changes button. And what it will do is it will use the key stored in the local storage for this particular project and will allow me to commit to this project. So now students, the enhancement from the previous Planet version is that students, even after they have created the project and published it, they can still edit it even after months. So let's say I'll just write commit message, which should be detailed. And yeah, so now the commit will happen. And I can also navigate through this entire project. So I'll just click on this get commits button, and you can see all these commit messages. So these are initial commits, and if I click on load this version, students will be able to navigate to this particular project's version. And if I just click on the initial version of this project, I will not be seeing those blocks. So this is like navigating through the history of this project. Now, all the planets, we stored all the projects, and we have a dashboard for showing all those projects. And similarly, we have here. So I can just click on all projects over here, and it will load some projects which I have created in the past during the, I think it, yeah. So this is the project which is present, and if I just go back, I can also navigate through my local projects. And what is happening inside is that it is creating a new GitHub repository for each project, and with theme as with the project data as the JSON block of the projects, and metadata storing additional information about the projects. And this theme of the project is added as GitHub topics for each project we create. So this allows students to fork projects also, similar to what we have, and you can just navigate to your projects, and you can see a list of projects which I have, and I can load any of these projects. Let's say I open a new project which I want, and I can now edit this particular project. So we have like a we are planning a gradual shift from the existing Planet system to how will students interact with this particular system. And you can see this, we can also see this particular project's commits. And yeah, this was about my project for this summer. You can also fork other people's project and work on them. So since this repository is not a fork and I'm on a time crunch, I will not be demonstrating, but yeah, this is what I was working on. You can find the details about this project on this particular link, GSoC 25, which is also my final report. So yeah, thank you.
Awesome, great work. Next, we'll be moving on to Music Blocks version 4 project. So Safwan Saeed, can you start us off?
Sure. So, hi everyone. I am Safwan. Well, this year I have been honored to do the project of Music Blocks engine, the Music Block engine, and yes, I have been selected. And then I also did. Uh, okay, am I visible? Am I? Huh?
Yes, you're visible. I'm asking Nikhil to stop sharing the screen.
Yeah. Yep. Yes. Better. So yeah, hi, I'm Safwan Saeed. So this year I have been selected in GSoC 25 for the Music Blocks version 4 to do the engine execution project. And then yes, so basically what Music Blocks 4 is. Music Block 4 is an overhaul of version 3, but we are trying to have it in a more organized way, more agnostic way, and then like in more plugin system way. So how did I achieve this? So basically what I did was we went through a lot of stages of planning with my mentor, especially in India. Thanks to him, he spent a lot of time with me, and then we actually discussed a lot of things. And then how we thought the engine would work is basically there are two parts. One is the masonry, and then second is the engine. The masonry is the front end, and the engine is the back end. So the engine will basically get the AST. what an AST is, let me just share my screen so that you will have an idea of what an AST would look like. Okay, so basically, yeah. Mm, yeah, so let me. Yep, so this is what the AST would look like. This is what I've hard coded this. This is what would look like. The masonry, which will be converted into an IR code that is from the compiler that I've designed. So this is what the compiler syntax would look like. And then this compiler generate the IR programs, which will be picked up by the scheduler. Scheduler will take these instructions and then assign it to the interpreter. What actually the interpreter does is take one of these instructions, execute them in a single line by line manner. And also for concurrency and all that stuff, we have tried to achieve it using parallelism because JavaScript does not support concurrency. So we've tried to achieve it using parallelism. And then, yeah, then there were a lot of testing and all that stuff. And then, yes, we also have these plannings and all that stuff we've done, like how the data flow diagrams would look like, how the AST, the compiler would like the parser, the symbol table, the block manager, how the IR program is generated, this how the IR is picked up, and all that stuff. And then this is how the scheduler looks like for multiple threads and concurrency. And well, yeah, of course, if you need to have a overview of my project, here is my repository. I'm going to share this as well. So I've just detailed description of what is achieved, what is done, and then what are the tests that we've achieved, how we've done, and everything. So, yep, if you want to have a look, you can sure go ahead and then have a look at this. It was a really great time working on this, had a lot of fun, had a lot of things to learn. It was really great. Thank you.
Yeah, great. Thank you, Safwan. And next we've got Saumya.
Hi, Devin. Hi, everyone.
Hello.
I'll be sharing my screen. Yeah.
Great. Yep, we can see it.
So I was also selected in GSoC for the Music Blocks version 4 project. My part was to build programs. Safin already explained all of this, but yeah, very quickly, what is Music Blocks? It's a virtual programming environment, and basically where you can use UI elements to code without actually coding. And why do we need to build version 4? Because version 3 was written entirely in HTML, CSS, and like plain vanilla JavaScript. And that's difficult to maintain and extend. Now we have React and TypeScript. So we are basically building an overall from the version 3. Before we dive into what I did over the summer, a few quick terms. What are bricks? These are the basic structural units we'll be using to build the programs. A tower is a collection of these bricks. Palette is where all the bricks will be structured and kept for the user to have an easy access. Workspace is a place where we actually build those programs. What is an SVG? SVG is basically custom vector images that we code up that don't break when you scale them. Uh, Model view, a model view architecture is where the view is everything that you see, the UI, the front part of it. The model is where you write all the logic and the structure for that view to work. AST, Safin already explained it. So basically, it's a tree-like structure for the code where we actually link the masonry and the program engine so that it actually gets converted to the final code. My primary goals for this project were to build a SVG-based brick system, implement the model view architecture on this, create the tower management for stacking and nesting, develop a palette for the bricks, then add the drag and drop functionality, enable collision detection, and finally build and integrate the AST with the program engine. For the implementation part, I'll just use my final report that I made. So initially, after the community bonding and planning all of it, we began with the SVG implementation. We implemented every single brick and the design, how the SVG should look. It's a simple brick. This is a expression brick. This is a compound brick. So after we had these individual brick components, we went on to create a brick factory wherein inputting some parameters like label, color, or slots, or what would the number of arguments be, you can generate any kind of brick with the brick factory. Then I went on to write the model and the architecture for the individual books to test this. You can see simple bricks that are stacked, then there's a expression brick, then compound brick with simple bricks nested. Then we had the single bricks. So we went on to build the tower model. So the tower model, I again wrote the model for it where we could manage the tower with like stacking it, nesting it, doing the traversals, bounding box calculation, and all those things were written in the tower model. But then after writing the model, we used the storybook again to check how the tower is being rendered with multiple compound bricks, multiple nesting, multiple stacking bricks. After testing this for every possible scenario for long labels, short labels, we now had the bricks ready. So now I worked on this with Justin, one of the contributors, and we built the palette system where you can basically have all over and you can see all the bricks. Then there's a drag and drop system. I use the React RL library for this. We use the quad tree detection, and also there's a brute force version for it. Basically, this is a drag and drop demonstration. You can drag any bricks from the palette and place it on a workspace. It can move around the workspace also. And yeah, pretty much it. And so the collision detection, basically, given any 2 points, if you see that two bricks are overlapping, it will basically show you that, yeah, there is a collision over there, and it sends back the feedback to the module to working on the disconnection part, and Justin worked on the connection part. So I rendered a dummy brick that would help me to basically demonstrate it. There's a dummy brick, and you can see that we can easily drag around, disconnect these towers, and the model stores all the value of how the tower is being disconnected. And the final part was the AST integration. So I wrote the configurations for how the AST should be rendered, and final part was to integrate it. I tested it for a few bricks, and basically me and Safwan will actually work together and then get this bridge connected, and then we have the masonry and the program engine which merged together is basically the version 4 of Music Blocks, which I have worked over this summer. That's pretty much it. And yeah, if you want to get into details of what I did every week, you can go on to Sugar Labs. My blogs are all present over here. Yep, that's it from my side. Any questions?
Great. Thank you so much, Saumya, and thank you, everyone. So this concludes part 1 of our GSoC DMP Sugar Summer of Code presentations. And join us next week, and we'll do another group of contributors showing their final work for the summer. So thank you for tuning into Sugar Labs, and let's give them another round of applause. Awesome. Thank you, everyone.
Thank you, everybody. Thank you, Devin.
Thank you, Devin. Thank you, everybody. It was a great summer all over.